Okay, chapter 2 is dealing with set. So of course you saw matrix before, I think, right? In linear algebra, no. In the anyway, later we have cardinality. Is also today I'm going to give you a brief introduction to cardinality. You heard about the sequence, right? And how to sum numbers. The sequence does not look like the previous one. No, here we are going to find the formula. Function of course, cal1, cal2, and set of operation and sets. So our focus today is on some concepts in sets. What do you mean by sets? So we mean the collection of what? Of distinct objects. So they should be distinct. Means that we don't have a repetition. What do you mean? We don't have such set like that. 1, 1, 2, 3. Okay? That one's called sequence, but it's not called a set. So in that case, we have the repetition is not allowed. So you have A equal to 1, 2, A, 5, B. So it's a collection of different objects, anything, members. Each of these elements, each of here is called element. Each item is called element or member. So I can say one belongs to A. So here's this symbol means that belongs, means that member. C is not belong to A. Why? Because we don't have C, right? Understood. So we have a belong, a member. So it means that C is not a member in our new set. That's all about A belongs, denoted by A element, and A does not belong to that one. Also, for example, we can translate sets to word or word to sets. What do you mean? For example, if I say n is odd less than 10, so I have O set. You say is equal to those numbers x belong to a positive integer number, okay, positive integer numbers, and x less than or equal to 10 or less than 10. Okay, so what's the difference between them? Less than 10. We can just translate this sentence to numbers. How? I say is equal to 1, 2 till 9. Understood? 1, 2, 3, 4, 5, 6, 7, 8, 9. What do you mean? I mean those numbers. Is that right? Yes. How about if I say Z? Sorry. How about if I say, let me the name of that one to be B. Yes, come on, come to inside from here. Good. So how about if I say O is a set that X belongs to the Z positive, but X less than 10 and X is odd. So we add another condition. Yes, so here O will be 1, 3, 5, 7, 9. So depending on the speech, depending on the question, we are going to construct our set because of different. If I have an even, you know how to choose. If I have an odd, you know how to choose. Do you have any question about it? So we have a number, word, name, it's a set. Understood? You need the set actually in the computer science and engineering, you know. In the computer you need it. Why? Because you are going to define your variables, at least. For example, you say X is string. Am I right? X is Z. No, X is ZE. Z evens. So it means that 2, 4, or -2, minus like that, 0. So depending on your loop, on your work, on your while that you want, you need to construct. Sometimes you need to construct a special set for you. You know? You need to construct some special. For example, you are writing a code, a program, to 3 peoples, A1, A2, A3. If you put this name, then you have the detail. Otherwise, you don't, right? So you have a condition. This condition depending on what? On the set. So you see Z belong to A, B, C, right? We have a Z. A is equal to A1, A2. For example, A1 is Ali, A2 is I don't know, Muhammad. A3 is Alan. So depending on this, you say if X belongs to A, then, right? Show me the details. Otherwise, do not print anything. So set is very important for you because you are going to define your subject, your program on this set. So that's why we say maybe contain name, numbers. We say February, A1 February, and for example salary, $200, $300, like that. Ellipsis means that extra, right? So I wrote 1, 2, 3, 4. You remember that. 1, 2, 3. I'm not going to write everything. For example, if I have 1 to 100, I'm not going to say 1 to write everything. So I say 1 to 100. If you somebody read that one, you know that we have 100 numbers here. And sometimes we have C equal to 1, 2, 3, and go. Means that infinite set, right? There is no limitation. We don't have any boundary. That's it. How about if I try to define set by words? For example, if I have this word, we have X is an odd positive integer and less than 10. What do you mean by that? We can change like that. We say, do you remember the rational number? How we define rational number? Do you remember? We say is equal to R. R is what? Such that. After the slash, we have a condition such that R is equal to AB. You remember rational number. And AB is where? Integer number. And, right? So we define set by short list. So when I say R, for example, when I say S belong to Q, in your mind, S is like what? S is like AB, any number, C, D, E, F, such that the numerator and denominator belong to where? Z. And I'm 100% sure that it's not equal, right? So any numbers, any variables, kindly do not play. Any variables belong to here means that belong to our set, means that satisfying the definition. The definition, what do you mean by definition? After the slash, conditions. You got it, dears? It's very important, you need for your work. Good. Here's you are. How about positive? Of course, they should be positive. Now we have the set of numbers. You know, when you say natural number, we symbolize it as an n, if you remember. We have natural number, right? What do you mean by natural number? We mean, for example, 0, 1, 2, 3. Some books exclude 0. Some book included. I don't know. Here we have it. Yes, we have. So 0 is included here. So this is the natural number. How about z, integer number? We say z is equal to positive n or negative n. What do you mean by positive and negative n? We mean that for example, we have a 0, 1, 2, 3, and also we have negative 1, negative 2, 2, 3. So that's why we called as a z. Look at here. We have that's a natural, that's a z, 1, 2, 3, and go on, and minus 1, minus 1, and extra. How about z positive? Look, that's why he changed the distinguish between z and natural number. Why? Because z positive is 1, 2, 3. They exclude 0. So when you saw in this book, we say, for example, n belongs to z positive, so 0 is not in my mind because we input what? Z positive. Z positive in our program, in our style, does not happen because there's some book put it here. So when we have Q, you know, when we have real number is good. So we have n, we have z, any z, positive, negative. Also we have Q. Am I right? What else we have? Which other sets do we have? Before imaginary, we have another set. We have a real number. Okay, real number is big. is the largest one. You are right.
Complex.
Before complex,
No. What's it?
that's a rational number. What else? Irrational number. What's the relation between rational and irrational? Shall I put a box like that? No. That's a rational number. Understood? Why? Because there is no relation between rational number and irrational number. Which set is collecting all of them? Which set is collecting all of them? Real number, right? Real number is collecting both of them. So any number is in real number, you can say is maybe belong to irrational or rational number. Which one is larger than all of them? Imaginary. What do you mean by imaginary? No, it's called something else. No. It's called what I said. If you want to recall natural number, you say 1, 2, 3. No, you say natural number. So which set do we have? You say that. That's complex. Yes, complex. Now we have complex number C. In some books we have C hash or something like that. So what's a complex number? All of them complex. All of them. Complex is the huge set till now. For now, we have a complex number is the largest one. After that one, you have real number. Then you have a part. Okay. So how's complex number? Complex number can be described as x plus or minus iy. That one is a real part. Means that all real number is one side. And that one is called imaginary part. Understood? What's the imaginary part? Here in imaginary in complex number, for example, if I say x squared minus plus 1 equal to 0. So tell me about the solution of that one. I say x is equal to plus minus 1. Am I right? If I'm in real number, I say has no solution. Understood? If I am in complex number, I say x is equal to plus minus I. You got it, dear? So how about something like that? So I say what? I say x is equal to plus minus 2, minus 4. Am I right? But I'm a 2-bit. Understood? So in that case, I have what? Look, the minus 1 every time will make you I, give you I. So that's called complex number, and you can see from here. Mentioned R positive and complex number. I'm not going to talk about that one. Of course, you know 1 and 2 means that 1 and 2. Here's open. That one is closed. 2 is include, of course. If you ask me about 2 in my set, yes, I have 2. How about 1? No, 1 is exclude. What's the difference between this set and that set? Can you tell me? A equal to 1 and 2. B equal to 1 and 2. Both is called sets. Why? Because we can represent that one as, am I right, Jamaat? Good. Wait. Here's the representation of sets. So, what's the difference between that one and that one? Yes? How about now? Are equal. Thank you. Got it. Well done. The first one, we are dealing with only single 2 numbers. Just only. 1 alone, 2 alone. But here, we are talking about how many numbers? Infinite, as he said. Because we have 1, 1.1, 1.999 till 2. When we exclude that one, which means that 1 is not here. We have infinite number. We have infinite number. 1 is not here, but 1 in the other one, just alone, as a single. How about the other one? No, we have single 1 and 2, but here we have 2 till the end of 1, but 1 is not included. Understood? So we have infinite numbers, excluding 1. Here we have only 2 numbers. If I have cardinality, for example, cardinality is the number of the set. For example, if I have A equal to A, B, C, if I ask you about the cardinality of A, it's called cardinality. Later we have a detail. So I say we have only 3 elements. Understood? If I ask you about the B, cardinality of B, I say you have infinite. I cannot give you any numbers. We have infinite. Why? Because B equal to, as we say, 1 and 2. Understood? Can you give me the number of the elements between 1 and 2? No. How about here? Yes, 1B, 1, 2, 3. Understood? Okay. Sorry. We have another things here. Empty set. That, I think it's the last one. Before that one, sorry. We have 2 equal. And then we have empty. When we say 2 sets are equal, means that 100%, all elements are in B. What do you mean? Means that, for example, if A is equal to 1, 2, 3, and B equal to 3, 2, 1, if I want to compare A equal to B or not, I say yes, 100% they are equal. Why? Because 1 is here, 1 is here. 2, 2, 3, 3. Understood? How about if I say A? How about if I add A or 4? In that case, no. Why? If I say, tell me why they are not equal, you say because 4 belong to B, but 4 does not belong to A. You got it? How to answer? Hello? Clear. So you should give me the clue. The example, that's why not. Yes? No. You mean yani like that? You mean, for example, C equal to 1 and 2 and D equal to 1 and 2? Yes, of course. Yes, equal. Because we have the same length, the same things here. Yes, they are equal. But if I say here, because at least I have single number which is not here. Why? Can you answer generally? For each, no. There exists, bring one example because it's not true. You remember, counter example. There exists one belong to F such that one does not belong to E. If you asked about that one, why? If you ask me why, I say for all elements in C or D, then you can find that element in D. Give me one element between 1 and 2, which is here and not there. Yalla. There isn't, right? Any element, up to you. Anything, yeah. Yes, yes. Even infinity, one by one, yalla. 1, yes. 0.001, yes. 1.002, yes. So all of them, generally speaking, yes. Right? Last thing for today, we have empty set. Empty set. Actually, when we are talking about empty set, especially in mathematics, when we have something the student didn't understand. But here we bring the good example in computer, so that's what helped us a lot. Of course, for you, for your department's clear. We have empty set, empty. Empty set can be symbolized as two things, two shapes. Only phi or singleton without anything. Understood? So that one and that one. If you ask me about the cardinality of here, IC is equal to 0. There is nothing here. Understood? But we have this. So tell me, this is empty or not? Is empty set or not? We have one yes. Yalla, one yes. No. No. Yalla day. Voting, yalla day. No كتير. To give you an example to understand. Yalla. Nose group. Give me the example to understand. To make us get the idea, yalla. Yes. What's inside it? I have a set. A in it. 1 in it. 1 and 2 in it. So how to describe that one?
That symbol means null, not means empty.
So still you say yes. Good.
No, it's not empty.
The question is, that one is empty set or not?
No, it's not.
Yes, take it. No. So give me the reason. Tell me why no. He say because null of null, null. Okay. You are right. Can you give more clue? يعني to. Okay. Okay. So the answer. Okay, why? Because we see that first, that one and that one. We have these two symbols. If they are not like that, it's not empty. That's the first. The second, to understand. In your PC, you know the PC? 100%? You know? Good. In your PC, if I have a folder by my name, and I have nothing, but the folder is empty, do I have a folder? Can I say empty? Yes, empty. But I have a folder or not? So because the folder exists, so it means that that one is not empty. Even if there is nothing in it. You understand now? We have a folder, nothing in it. But here, we don't have a folder. If you search for my name by Dilan, you find my name, right? How about in the second PC? You can find the folder, right? But when you click, there is nothing. But for the second, if you search, there is no Dilan. Understood what I mean? So this means we have that. This means we have that. Or that. Or. Clear. Thank you. Wallahi, your example in this book, it was make me happy. Because when we are talking with a student that we have empty with nothing, but it's not empty. So you see how we imagine. It was without this example, I couldn't explain more. Yes. Yes. Exactly. We should delete from the protocol. Thank you. You know what? Listen to me. Sorry. You can actually. He's right. You can see it in your mind, in your direction. He says something. He was right, but I couldn't explain for you because you couldn't understand. But that my also he says something the same. But our example is general. Everyone can understand. That's it. Yes.
The example is like
Now I don't. Tell me later. Together we discussed. Okay, sorry. Together we discussed that. We have a Venn diagram. Sorry, Venn diagram is what? Just a diagram to show things. For example, A equal to R M A, right? So if I wanna show A, I say R M A. Understood? That's it. So Venn diagram. That's it. If I have a Z, for example, I want to say A equal to 1, 2, 3, compared with a universal set, we have U for universal set. Means that, for example, I'm going to talk about natural number. My universal is natural number. Inside natural number, I have 1, 2, 3. You don't have a comma. Just that's the Venn diagram. So that's all about today. So next lecture, we are going to